Hi, welcome to Cloud Meet Edge. Today, we'll be talking about how to deploy AWS IoT Greengrass using Docker Containers and Ubuntu Snap. I'm Tatiana Cook, a Senior Product Manager at the AWS IoT Greengrass team.
And I'm Ankit. I'm a Software Development Engineer at Greengrass team.
And later on, we'll be joined by Alan Findley and Gary Bruns from Prologis and Toban Zolman from Rigado, who will talk a little bit about how Greengrass fits into their architecture. Before we get started and talk about Greengrass, I'll provide a little bit of background about AWS IoT services that you can use to help extract value from information that you're gathering at the edge. AWS IoT services can help you do a few different things. They can collect data from devices that are operating at the edge, and that's the area where Greengrass works best, and I'll talk about that later. They can help you control, manage, and secure devices, and get valuable information out of that IoT data that you can aggregate in the cloud. We have a full stack of different services that AWS provides that work nicely together. And that starts at the device level with things like our IoT Device SDK, Amazon FreeRTOS, and AWS IoT Greengrass. That information then integrates with some of our cloud-side services like AWS IoT Core, our device management service, and Device Defender, a security tool. Finally, you can take advantage of AWS IoT Analytics to aggregate and view information so that you can extract meaningful insights from all of the data you're getting from your edge environment. We like to think of this as creating an IoT virtuous cycle, where you can put software down onto your devices, control those devices, and then get data that you aggregate in the cloud to build intelligence and drive better outcomes on the edge. Today, we'll be talking about how to extend AWS cloud capabilities to the edge using Greengrass. Greengrass extends AWS IoT onto your devices so that they can act locally on data that they're generating, whether or not they're connected to the cloud. This helps customers with what we call the three laws. The law of physics, which means that information can only travel so fast. So if you're sending all of your data to the cloud, you might encounter latency issues. The law of economics, which means that sending information to the cloud carries a cost. And the law of the land, which means that in some cases, you might not be able to send information from your edge environment to the cloud. AWS Greengrass helps you with this through a variety of different capabilities, which I'll spend a few minutes talking through before we get to our demo. First of all, Greengrass provides a local messaging environment, and that allows you to use an MQTT broker that's part of the software service to publish and subscribe to messages, whether or not those are messages you're sending between your Greengrass core device on the edge and other edge node devices, maybe a device running Amazon FreeRTOS, and send MQTT messages up to the cloud. This means that even if your cloud connection is broken, your local Greengrass messaging agent can continue to control and communicate with devices in that edge environment. Greengrass also allows you to take local actions. Because it provides a local Lambda runtime environment, you can write Lambda functions in Python 2.7, Node.js, or Java up in the cloud, test those functions, and then deploy them to run on your edge device. And we'll show you an example of that in action today. Greengrass helps manage data and state synchronization. Through a local shadow, you can have actions that occur locally and change your device state. Even if your device is offline, when it comes back online, your cloud-based shadow will synchronize with that information and update the local state of the device to be reflected in the cloud. Greengrass also provides security. It enables TLS mutual authentication so that messages that you're sending are protected. Greengrass devices all have X509 certificates and encrypt information that's resting on the device or in transit. We also have some capabilities that allow you to take advantage of hardware-based root of trust and integrate with secure elements such that the private key you use to encrypt these messaging channels can't be accessed even if someone gets physical control of your device. Greengrass helps customers with things like accessing local resources on their edge devices, something that can be a bit complicated when you have a container environment like the one that Greengrass provides. That means that if you have a camera that's streaming information locally, you can program your Lambdas to interact with that data stream and provide meaningful insights in your edge environment. Greengrass also plays really well with a lot of the machine learning tools that AWS is developing. For example, you can train models in the cloud using Amazon SageMaker or another service in EC2, and then deploy a version of that model to run on a smaller footprint device, compiled to run on that device architecture so that you can have ML inference happening closer to the source of a lot of that streaming information. Greengrass also now has connectors, which are pre-built applications that make it easy to integrate with both AWS and other services, whether that's Kinesis Firehose or a third-party service like Splunk. We also integrate with AWS Secrets Manager, so if you have a secret that you want to include in one of your Lambda functions, you can deploy that secret securely to rest on your edge device. Finally, Greengrass provides over-the-air updates. As the service continues to evolve and our team and our hardworking developers like Ankit continue to build new capabilities, even if your device has been deployed in the field, you'll be able to send the newest version of your software down to that device without having to physically go and interact with the device itself. This means that you're essentially future-proofing your IoT architecture because you'll continue to be able to take advantage of security updates, new features, and bug fixes as the software evolves. Now, you're probably pretty excited about Greengrass because I listed a bunch of awesome features, and you might be interested to learn more about what kind of hardware devices you can use to deploy this software to. We have a new tool that we launched at re:Invent this year called AWS IoT Device Tester, and it's a test automation tool. So if you have a question about whether or not a hardware device you have can run Amazon FreeRTOS or AWS Greengrass, you can download the AWS IoT Device Tester tool and run that tool on your laptop, communicate with the device that you'd like to run Greengrass on, and figure out whether or not it has the necessary requirements. If you don't want to go through the testing process, we also have devices listed in our Partner Device Catalog, and that includes information about device specifications themselves and the versions of Greengrass that they've been qualified for. So I'd encourage you to go check that out. Greengrass runs on a variety of different architectures and operating systems, and while our officially supported platforms are x86 and ARM v7 running Linux operating systems, you might be interested in running Greengrass in a dev environment or on a system that doesn't have Linux. We're excited to say that Greengrass can now run in other container environments. So that includes both inside of Docker containers and using Ubuntu snaps to deploy Greengrass to run on your device. The way that this works is by introducing new configuration flexibility for the way that Greengrass handles containerization. By default, all Greengrass Lambdas run inside of a container environment, and Greengrass provides an underlying container layer. That gives you the benefits of isolation and security that you generally think of when you think of containerization. However, in some cases, for example, if you want to use another container like Docker, you might want the option to run Greengrass as an OS process. That means that your Lambdas and Greengrass group won't have a container environment, and you can deploy Greengrass to run in another environment that either is a container itself or doesn't have the capability to run containers. You might also be interested in keeping some of your Lambdas in isolation in those containers, but having a few of them run as OS processes so that you can directly access certain types of devices, like a USB resource or a Bluetooth Low Energy device that doesn't have a fixed file path, so that you can't configure through local resource access. Greengrass now has these group and Lambda level isolation and permission settings, and I'll take a moment here to show you where on your Greengrass console you can access them. As you can see here, I've set up a Greengrass group for this webinar, and the change that I would make in order to be able to configure this and to have different permission and containerization settings is down here under Lambda Runtime Environment. This is at a group level. So for example, I might not want to run with the default permissions, Greengrass Core User and Greengrass Core Group, but I might want to use another user ID and group ID. In this case, I'm setting my group to run as root. Here, I might want to remove the container environment and say that I want to run Greengrass with no container. I'll update my Lambda execution configuration. There's a little note. There are some security benefits that come with containers, so be careful when you make this change, particularly if you're planning to run your group with root permissions. But after I've made the change, you can see that it's been successfully registered, and I can go and move forward and maybe now deploy this group to a Docker container. This means that you can now run Greengrass in Docker on Mac OS X or Windows 10. Now I'll hand it over to Ankit, who is going to cover a demo that he's pulled together. that shows how you can deploy Greengrass to your Windows laptop and run a smart fan in your local environment. So we've got some water here to imitate real-world environmental conditions that you might run into, hot and cold environment, and a fan setup that Ankit's going to talk about that shows you a little bit about how you can have local event response action running on a laptop that controls kind of this miniature fan here. So I'll hand it over to him.
Hey, thank you, Tatiana. That was a really good introduction about like the Greengrass and the offerings of Greengrass, and also like the demo that I'm going to be showing today for our device lab cooling system. So we have like this whole setup in our device lab, but just to show it as a demo, I basically miniaturized the whole thing. And what you are seeing here is basically two Greengrass aware devices. We call them GGADs for short. So throughout my demo, I'll be using GGAD quite often. So what these devices are doing, so we have a temperature sensor which is reading the temperature, and on the real time it just sends the temperature reading to the Lambda function, which is running inside the Greengrass. And as you know, the Greengrass is running inside the Docker container, so it basically is seamless to just run Greengrass on any platform, be it Windows, Mac OS, Linux. As long as the platform is running Docker, Greengrass can run on it. After that, once we have got the signal on the Lambda from the temperature sensor, we send the shadow update to our shadow device, which is fan in our case. And as soon as fan shadow gets updated with like the status about like to turn it on or off, shadow, the fan gets on or off accordingly. So as we move forward with our demo, I'll show like how the circuit diagrams looks like. So yeah, as in this slide, you can see that we have two components. One is the temperature sensor with 3 prongs, and one is the actual fan with 2 plus and minus. So as you can see, the 3 prongs that are coming out of the temperature sensor, one is for feeding in the power, that's the red wire. Yellow wire is for getting the signal or reading of the temperature. And we have blue wire as the ground to complete the circuit for just the temperature sensor. After that, we have the fan motor, which is positive and negative. Red one is the positive, which is fed into the GPIO 16 pin, and ground is negative. So that completes the circuit for the motor. As you can see, that both the devices are plugged into the same breadboard. That's because we are controlling both the devices using the same Raspberry Pi. And that Raspberry Pi communicates with the Greengrass over the Ethernet cable, and sort of gives you a feel of like a local intranet version where we are not contacting the cloud for any of the signals coming from the internet. Now in this slide, I'll be going over like what the components of Greengrass group looks like and how we are controlling different devices and facilitating all the communication between devices and Lambda, and then Lambda to devices. So there are like two components, as I said. The first piece of communication is between the device temperature sensor to the Lambda. So you can see like the 5th subscription is for that. Temperature sensor sends a reading to the fan controller, which is our Lambda, and they talk over the MQTT topic, which is room temperature. After that, we have to update the shadow document for the fan device, and that's been done by our local shadow service, which basically been talked by the Lambda, which sends a signal to update the shadow document, and it gets updated accordingly. And then based on the current state of the fan shadow, we turn the device on or off on the real time. The condition for turning on or off the device is basically we have the temperature threshold set as 85 degree Fahrenheit. As soon as the temperature goes up, we turn on the fan. As it goes down, we turn off the fan. We have to bump the temperature up because the room is already too hot. So just to come clean about that. After that, we have two devices in our device tab, temperature sensor and fan device. All they are doing are the logical representation of our devices. This helps us to get the credentials and certificates to deploy that to the device itself. Next slide is about the fan controller. This is the logic that the Lambda runs to differentiate how to control the fan's shadow. And in the end, to make this thing work seamlessly on a Greengrass running in the Docker container, we have to use no container mode. Otherwise, we'll see issues where basically container inside a Docker would not allow you to run any of your AWS Lambdas in Greengrass. And now this is the deployment. The whole setup gets deployed to the Greengrass, which is running in the Docker container and can control all the logic locally without any communication with the internet. All right, so as we have this demo ready for us to showcase, I just want to quickly go over how this is deployed and running inside the Greengrass container. So as I showed earlier in the slides, this is the actual Greengrass group that I'm deploying onto the Greengrass Docker container. And this is where the Docker itself is running. So let me quickly switch my screen. Awesome. So as we can see that we have to run the Docker container for running the Greengrass in it. So I have my Docker command set up for here to run that. As you can see, the Docker run starts the Greengrass container. And after that, we are using an entry point, which has already been injected inside the Docker image. We have to also bind mount 4 directories for sharing the creds and certificate with the Greengrass container that we are doing with these bind mount points. As we can see that it's using my local location for search config to bind mount them inside the container. After that, we can also bind mount deployment and log folders inside the container just to persist those artifacts across different container run. In the end, we are also sharing the port 8883 from outside the container to inside the Greengrass container because Greengrass talks MQTT and we need to expose that port inside the container. And in the end, I'm using Amazon AWS IoT Greengrass image that is hosted on Docker Hub. So end customers can use that seamlessly as soon as they get hold of Docker. When I press enter, we can see that the Docker container is running and it's running Greengrass in it. So here you can see that Greengrass does its setup and in the end it shows a message Greengrass successfully started with bit 12. And this is a proof that Greengrass is running and it holds the control for the command prompt. So as soon as you are done with your experimenting and demo, you can hit a Control C to sigterm the process which is running inside the Docker container. And it does it by cleaning the resources that it is using. So it's a clean termination. In the other command prompt, you can see that I have already SSH'd into the Raspberry Pi to control my devices. One command prompt is for temperature sensor, the other command prompt is for fan device. First, I'll be controlling the fan device to listen on a shadow document for its state changes, and then I'll be sending the signals to the temperature sensor. So for controlling the fan device, I have a basic command which basically tweaks the Python code for the fan device, and it talks to the endpoint for basically getting the connectivity information for the Greengrass core. After that, we are using the creds that are being assigned by the IoT when we are provisioning our new devices. And in the end, we have to say that the thing name that we are using is fan device. That helps the code to know that, okay, which shadow document it should be listening on. As soon as I press enter, it does its connections. And in the end, it will just be started listening on the device shadow. So you can see, subscribe to the Delta topic for device shadow, fan device. Now here, I'm using a temperature sensor, which I'll show how these are running. So you can see the command is basically Python temperature sensor.py. It is using the same endpoint for my core. After that, we have again credentials and root CA to give the creds to the device. And the thing name is temperature sensor, as we have already seen that in the Greengrass group on the console. And the topic that it is using is room temperature. As soon as I press enter, it basically starts sending the temperature signal onto the Greengrass core, and Greengrass core will then send the shadow updates to the Greengrass device, which is fan. So as you can see that we have started the temperature sensor and it's reporting its state of basically the fan controller is reporting the state of the fan and the temperature reading that's sensing. Right now the temperature is 78 degrees Fahrenheit and the fan status is off. Now Tatiana is going to be raising the temperature of the temperature sensor by touching some hot water. As you can see, the temperature started going up to 80 degrees Fahrenheit. As soon as it hits 85, we can see the fan turning on.
Great. And is this occurring from Lambda execution on the Greengrass device?
Yes. So the fan controller is doing all the things locally. Nothing is happening from the internet or cloud. Greengrass just has the ability.
Cool. Okay.
All
Looks
right.
like we're almost there. So we should be seeing the fan go on at the 85 degree
85.
threshold.
Yep. Anytime soon.
Okay. Let's see. Cool. Awesome. Looks like the fan went on.
So this basically does that the control happens through the Lambda function, and it controls the Lambda, the fan device. After that, we can quickly see if the temperature goes down. The local Lambda would know how to control the fan on the go without having to do with the cloud.
Okay, so if we're cooling it off, you can see the fan. Looks like it should be stopping soon.
As we saw that the fan just stopped working after the temperature went down after the 85 degree threshold. So as you can see, all the events are happening locally with the Greengrass running inside a Docker container, and no interaction has been happening over the internet for controlling the fan.
Cool. Thanks for talking us through that. We'll have versions of the Greengrass Docker image that are available both through Amazon ECR and on Docker Hub. So if you want to try this out yourself, it's pretty easy to get started with Greengrass running inside of a Docker container.
Yes, Docker Hub is pretty seamless. We can just simply do the Docker login and then just get the image locally on any platform which supports Docker at this point.
Great. Thanks so much for running us through that demo.
You're welcome.
Now I'm excited to welcome Alan and Gary, who are joining us from Prologis Labs. And they've been using AWS Greengrass, and we'll talk a little bit about how Greengrass fits into the architecture of what we're kind of nicknaming the warehouse of the future, some cool new technology they've developed.
Yeah, thank you, Tatiana. So before we dive into the architecture and tell you a little bit about Prologis and why our scale is so significant to the task that we have at hand to leverage the Rigado platform and the Amazon Greengrass platform. So Prologis is the world's biggest commercial industrial real estate company. We manage over 800 million square feet of real estate around the world in 19 countries. That's a huge footprint. And that footprint represents about 2% of the global GDP of all the products that flow in and out of our buildings on a yearly basis. So, you know, we look at these buildings and how we operate them in a very different way as time has changed, or as time's gone by. We're now looking at it as, how do we take that footprint and start to put technology in place in that footprint that can help us as a landlord to manage that building more effectively, and how can we use the technology and help our customers and our partners in that space. So, you know, with that broad footprint of technology, or broad footprint of properties around the world, we have a very diverse set of customers. And of course, it's not surprising that Amazon is our largest customer, since most of our business, a large portion of our business, is driven by e-commerce. So when you think about our customers are leasing anywhere from 10,000 square feet on up to over 1 million square feet with us, we've got to find a technology solution that's very flexible, very scalable, and very secure. So we created a lab in San Leandro, California, that we call Prologis Labs. And in that lab is where we're experimenting with this technology. And the way we think about it is that we often talk about, if your building could talk, what would it tell you? And when you use IoT technologies in that footprint, that building now comes to life with information that it can share with you that couldn't share with you before. Things very similar to what Ankit was showing in his demonstration, right? Yeah. Temperature, vibration, what's a snow load on the roof? Are doors open? Are lights on? How are my assets moving in the space? Do I have a truck at a dock door? Those sorts of things. So this partnership with Rigado and Amazon is really important to us to create this digital infrastructure. It's going to create the warehouse of the future for us. So I'd like to turn it over to Gary and let him dive into the technical architecture around what that footprint looks like.
Thanks, Alan. We'll try to go through this at a fairly high level. You mentioned security, scalability, simplicity, and flexibility. These are the things that are really driving our architecture. So if you start over on the left side, this is the edge. These are the devices that would be in the building and the technology in the warehouses that you mentioned. And on the right would be the cloud. The Rigado gateway over on the left is really a key piece of our architecture. So we really like the Rigado gateway, which runs Ubuntu Core as an operating system. Their model for delivering this for us is as a service, so we don't have to deal with the operating system patches or the hardware. They provide that, and it's a really reasonable cost on a monthly basis. Our security architect, who's a very exacting person, as you know, Alan, was not very happy with most of the IoT partners that we spoke with. When we got into the Rigado architecture, we made him happy. So that alone was worth quite a bit from our side. Moving down that stack, so Ubuntu Core, of course, has snaps, which are containers. So the containers are really important for the flexibility you mentioned because of the diversity of our footprint of customers inside of our buildings. We don't know what they're going to do. We don't know how they're going to do it. But we're trying to build this infrastructure so we can make it easier for them to do what they need to do. So we may have a light manufacturing client, we may have a customer with 3PL, we may have e-commerce, as you mentioned. So having containers at the site, at the edge level, is really important for us so that we can essentially run our stuff alongside of their stuff or a partner stuff, whatever that might be in the same package, but with pure isolation. So if we move to the left of this diagram, you'll see the devices. Similarly, we don't have a lot of control of the devices. We'll have our own devices to manage and monitor some of the environmental conditions and the building conditions, but we'll also have devices from partners and the customer themselves. So the scalability comes into play here as well. So 1 million square foot warehouse, like you mentioned, is pretty big. When you walk into that space, it's stunning, the volume. Finding an IoT network that works in that space was not an easy task for us, as you know, Alan. It was there's a lot of things out there, a lot of things that are really geared toward, no offense to Raspberry Pis and home devices, but it doesn't work in 1 million square feet. So we found a partner called WirePass, and they have a Bluetooth mesh network that really helps us kind of scale out these devices, both in volume, scale in terms of space, as well as density. So we may also have a customer that has a lot of product in a very small space. So being able to discern the signals is really important for us. So back to the Ubuntu Core snaps, WirePass has a snap that runs on Rigado. Rigado and WirePass are partners. This gives us this ability to plug and play, essentially, the communication mechanism to the Bluetooth devices. Moving on now to Greengrass. So what we found was running Rigado gave us a lot of extra capability to deploy code onto that operating system. But it was still pretty difficult work to code at the operating system level and deploy. So we wanted to look for a solution to make this simpler for us. So Greengrass comes into play here. We love Lambda. We love Lambda in the cloud. We wanted Lambda on these devices too. So Greengrass was a perfect fit for us. It gives us that flexibility so we can run code in Greengrass when we need to run it. But if we also need to run a partner or a customer's software on another snap, it's not an issue. One of the other features Tatiana mentioned was the connectors. So we're really excited about these connectors that come with Greengrass. You'll see there's Modbus connectors. So this is where we would control devices in the building. Our fans are a little bit bigger than the fan we saw in the earlier demo, but it's the same basic concept. How do we connect to those fans? How can we control it with the Lambda function? The Modbus connector, we think, is going to really fill that need for us. We have notifications, of course, for on-site events, a lot of security processes, or safety. One of the examples, safety is a good example that I think you mentioned, Alan. If you think of a warehouse, there's a very large slab of concrete, right? 1 million square feet, that slab of concrete is a heat sink, so it'll stay at a certain temperature. When the doors open on the dock doors on a very humid day, just like that glass of water you might have, you'll get condensation right at the dock, which becomes a safety hazard. So for us to be able to predict that and notify or kick a fan on to reduce the condensation are the scenarios we're looking at. So moving over to the cloud side, the other connectors that we're interested in besides notifications would be the Kinesis data fire hose. So keeping things simple, feeding data right up streaming into an S3 bucket to feed into our data analytics path, as well as sending it down to either our customers' endpoint or to our marketplace that Prologis provides called Prologis Essentials. Quickly moving from left to right, so we then load that data into an S3 bucket, into our data lake, which is composed of Snowflake and a data virtualization platform called the Nodo, as well as analytics on the Tableau side. Circling this back around to Greengrass, the smart building for us is really key, of course. SageMaker is a component here that we plan to use to start to learn and understand these conditional changes, like the condensation example, feed that back to Lambda, and then run those execution models on the device.
Cool. Thanks so much to both of you for joining us and talking a little bit about all of the cool new technologies that you're building into your warehouses to help deliver value to the customers like Amazon and many others who are taking advantage of them.
Great.
Thank you.
We've got Toban Zolman here from the Rigado team as well, and he's going to talk a little bit about some of the work that Rigado's done to help enable Greengrass to run on the Ubuntu Core environment that the Prologis team talked about. So at this point, I'll hand it off to Toban. He's the VP of Product at Rigado.
Cool, thanks. So I'm going to go through a few things. I'm going to show the process of installing a Greengrass snap onto a gateway, talk through deploying Greengrass code to that gateway, and then show an actual functional solution that we currently have running in a warehouse a couple 100 miles away from here right now. So I guess to begin, let me just take a couple minutes and explain a little bit about Rigado. So we provide IoT data solutions for smart building environments. We do this across a host of different markets, things like smart logistics, like we've heard Prologis working through, hospitality and restaurants, smart office buildings, as well as things like healthcare. And through that process, we've deployed over 5 million devices and have solutions working in about 80 countries and growing across the world. And the way in which we approach those solutions is really as a simplified edge as a service solution. So the concept behind this is that Rigado can bring sensors or connect to third-party sensors, run edge intelligence, whether that's Greengrass or integrating sensor data directly to an MQTT or HTTP endpoint. And then while your data is flowing to the cloud, Rigado manages all of the security, the updates, monitoring, and orchestration of everything that's happening at the edge. So that's the approach that we've taken to these deployments. In the context of what Prologis was discussing, I wanted to talk through the type of deployment that would be on Rigado hardware, leveraging Greengrass as the intelligence that's really happening at the edge. So in this architecture overview, I'll actually show this working live, but there's kind of 4 pieces to this architecture. Starting in the lower left-hand corner, we have low power wireless using BLE asset tags. These tags would go on pallets and boxes on hand trucks, kind of you name it, that would exist inside of a logistics facility. They would be beaconing out their ID, which would be correlated to a particular package or pallet or whatever makes sense. In addition to that, they would also be advertising out environmental information such as temperature. So if you are shipping a package, let's say that has vaccines or food that needs to be kept at a particular temperature, what this solution would do is allow that environmental data to get collected by our gateways that are running Greengrass, and then have business rules act on those depending on what needs to happen. So as an example, if you look at our gateway, kind of this larger area of the diagram, there's actually a host of things that are happening here that are worth kind of understanding. So at a basic level, we have the IoT hardware, which for Rigado means we have a host of low-power wireless radios that will power different IoT solutions. In this particular example, what we're leveraging is Bluetooth or BLE. On top of that, we are running Ubuntu Core. The advantage of Ubuntu Core is that it's a fully contained environment. And so everything that runs on top of that, including the kernel itself, is isolated or contained into a separate snap. And each of those snaps has a predefined and pre-configured interface to every other snap, which means you have high levels of security, high levels of confinement, and it lets you update each portion of the system independently of each other without really affecting overall system stability. So what that enables us to do is we can drop in the AWS IoT Greengrass core snap that's running Lambda functions. And the advantage of how we've architected this IoT gateway is that we've basically put an API layer between Greengrass and the underlying system. This lets Lambda simply call a REST API to do things like scan for Bluetooth beacons or even do command and control over Bluetooth devices. And so that's what the Rigado Edge Connect APIs offer. And then finally, running next to Greengrass is our own Edge Direct agent, which lets us pull monitoring information, system stability information off of those units, as well as do things like configure it for the particular network it's on. So if we drill in a little bit to the Lambda function itself that we have running in this particular example, there's actually three different things that we have communicating back to the AWS cloud. Initially, we have the connection back to AWS IoT Greengrass for us to actually deploy the Lambda functions to the edge. We are streaming data up using Lambda to IoT Core, where we also have an IoT rule that is feeding that data into Amazon CloudWatch. And finally, the Lambda function at the edge can also alert out based on temperature thresholds being exceeded, and that feeds into an SNS message that can alert service providers on the ground to take action on a particular package if it is starting to exceed temperature thresholds. Now, the reason we've kind of broken these communication threads out is actually pretty intentional. In a production environment, you may not want to stream all of that data to the cloud all of the time. In a 1 million square foot warehouse, you may end up with some gateways that are leveraging cellular backhaul for connectivity. And so in those cases, what Greengrass gives us the ability to do is actually pick and choose what data goes to the cloud and do things like anomaly detection and just send that up so that we can have more intelligence at the edge and just surface actionable data into the cloud. So let's kind of take a look at what this actually looks like in practice. I'm going to switch over here and show the CloudWatch dashboard just to give us a sense of what this data looks like in practical terms. So it's just refreshing here. So as this loads up here, what this is doing is it's surfacing a host of environmental data, including temperature, pressure, and humidity, which really lets us do alerting around environmental thresholds being exceeded. In addition, we are surfacing signal strength, which we leverage for location and positioning. So this is used extensively in large facilities with multiple gateways where we can read signal strength of a particular asset tag across multiple gateways and figure out which area of the building a particular package would be in. So we could identify this package has exceeded the temperature threshold, it's in building 3, zone A, and an operator could go address that. In addition, we also surface some other maintenance level information like battery level, so that if a battery level is starting to get too low on like a vaccine or some other temperature sensitive package, that can also be identified and preventative action can be taken on that. And then the final thing that we are surfacing and can also leverage Greengrass to take advantage of is reducing the rate of how often a sensor pings out if it's within certain thresholds to extend battery life. So there's an awful lot that's happening here, both at the edge and in the cloud, to kind of build a comprehensive solution around location and environmental monitoring in a logistics environment. So what I want to do is switch over real quick and show just a couple pieces of code that are running at the edge. We're going to make one quick adjustment to that and then literally go through the whole process of deploying a Greengrass snap and then deploying an update to that snap based on tweaks that we make here. So initially, I wanted to show this is part of the Lambda function that is hitting a local REST API, in this case to scan for beacons that are advertising out this location and environmental data, as well as an additional endpoint to make adjustments to the settings of those devices. So this lets you leverage Lambda functions to actually interact with Bluetooth over a wireless radio, which is really pretty cool. And then the second piece of this is the collector function, where we're able to fire off SNS alerts based on certain temperature thresholds being exceeded. So right now this is set to 10C. I'm going to bump this up to 15 and save it. And we're going to come back to this in just a second and deploy this out to a gateway once we have the Greengrass snap installed on it. So I'm going to switch over here. Here we go. To Edge Direct, which is Rigado's orchestration and monitoring system that works in conjunction with canonical app stores. And so essentially what Rigado has done is taken the app store model that Canonical provides, and we've wrapped some additional enterprise tools around that to map deployment of snaps into a typical enterprise workflow. So in this particular case, we have our app. So I've got a preview of Greengrass here available as a snap. And I've got this available across multiple channels as the construct that Canonical leverages for this, where you could essentially promote software as it gets more and more stable, from edge to beta to a release candidate to stable, and then choose which of those channels gets deployed to a particular device. You can then take multiple snaps and bundle those together. In this case, I'm just going to keep it simple, and we'll put the Greengrass preview snap from the stable channel onto a series of devices. And I'm going to choose to deploy this to any gateway where the customer is Prologis. So I'll save that. And it found one gateway that meets that criteria. So if I jump over here to my gateways, I'll just click on the first one here. And this one is tagged with Prologis. We can see here the CPU is starting to spike. And if we look at this little vertical bar, we can see that it's already starting to install the Greengrass preview. So this is a kind of the workflow that we would leverage in a large scale deployment to get the right software on the right devices and ensure that that software is from the appropriate level of risk. Is it a release candidate or stable? And also be able to push additional configurations out to that. So for the sake of time, I'm going to cook and show my way through this a little bit and skip over getting keys installed on that device. But effectively what you would do is follow the wizard on AWS IoT to add the device to a Greengrass group, generate keys, and then leverage Edge Direct to push those keys out to each individual device. And you can do that along with network configuration and other pieces to get each device on the network and communicating directly with AWS IoT. So we've got that set up. What I want to do now that I have already made a change here to my code is I'm just going to run a script here real quick to zip all of the Lambda function and all of its dependencies up real quick. I'm going to jump over to the Lambda management console. And what I'm going to do is jump into my Ruby collector, is what we've called this function. I'm going to upload this new zip package. So I'll do that and save that real quick. And what I'm basically going to do here is once I get this uploaded, I'm going to publish a new version. I'm going to say this is a temp threshold increase. I'm going to publish this. I am then going to set this as the deployment version. So what I just uploaded should have been version 18. So I've got that. I'll save that. So that's now ready to deploy. If I come over to AWS IoT and go to Greengrass and look at my groups, I have a group that's already set up that has these gateways inside of it. If I look at my deployments, I can go ahead and deploy again since I just put version 18 into that. It has started the deployment. You can see here that it is in progress and it's pushing that new Lambda function down to each of those gateways. So these units are all, like I said, several hundred miles to the south of us right now in a commercial building. And as soon as they get this updated code, it will change the threshold in which it alerts out to SNS. And so this is a really effective way to deploy code, to do intelligence at the edge, and then kind of pick and choose where that intelligence needs to live and what data goes up to AWS Cloud and what stays at the edge. So it's been a really effective way for us to solve a lot of the problems that we see in use cases like Prologis is tackling. Yeah, so that's it in a nutshell.
Awesome. Well, thank you so much for running through that. I think we may leave your deployment in progress for now, but it looks like you've had some successful ones in the past. And thanks again to you and the team at Prologis for joining us. We're glad to have had the opportunity to show a few different channels that you can use to deploy Greengrass. Thanks.
Yeah, cool.